All right, up next, we have Padraig from ZEDEDA and Garud from SLB. They're going to be doing a little bit different style, more of a fireside chat, talking through how AI and real-time are reshaping oil and gas operations on the ground. Gentlemen.
Who wouldn't like an Irish and Indian have a conversation on dais just before lunch?
That's right, yeah. So we'll do this. So what we decided, so first of all, thanks for the introduction. My name is Padraig Stapleton, Chief Product Officer at ZEDEDA. Garud, I should introduce yourself.
Garud Sridhar, I'm the head of product for what is called intelligent operations in SLB.
Yeah. So what we thought we'd do is, rather than subjecting you to a few more PowerPoints, we thought we'd just have a conversation about the challenges of deploying AI at the edge. Like, what are the both process, technology, and other types of challenges that need to be overcome in order to make this happen? So I think one of the first things really is trust, right? I think, you know, everything we do in life requires a degree of trust, either in who we're working with, within a company, or the companies that are partnering with, et cetera. So when it comes to deploying AI at the edge, how do we get to a point where we can trust AI? How do we get to the point where we can let AI do certain things versus give up control on other aspects of the edge that have been done by humans in the loop historically?
I think that's a great question to start with. I think trust is something which we all need before we can adopt anything in our personal lives even, yeah? Probably at this point, I might not be wrong if I say there are maybe 10,000 commercial aircrafts flying in the air, doing micro adjustments based on various conditions, fuel, speed, etc. And probably what, 200, 250 people sitting in there and they're not even thinking about it, right? It's happening in the back end. Yep. Now, that did not happen overnight. That industry came through several decades of building up that trust. You know, initially it was perhaps, you know, just holding steady the flight height. Then came some kind of micro throttling, right? Then came the ability for you to do some full flight management over time. I think our industry is in the same maturity curve, maturity path. And if I were to draw a comparison, I would say probably we are a little bit ahead of the throttle control, right? So I think it's not too far off in our industry where we are adopting these technologies to achieve benefits. I personally say, I think we have had a lot of these new technologies, call it ML, AI, data science enabled in some form or fashion, to help the people who already sit in some fancy offices, who have these lovely big screens, seeing squiggly lines show up, pie charts, graphs, insights generate. You're already making their life, whose life initially was good, a little bit better, giving them some incremental value. And then in our industry, we have, I can bet, more than 50, 60% of our sisters and brothers who go to the field to make changes, to make adjustments. And I think that is where we as leaders in this industry should have the passion to make their life better, right? And small incremental changes in terms of giving them things, giving them tools which help their life being better. Yep. Alarms which they can trust, not a flood of various colors popping up in front of them which they have to go through, etc. So I think it's more of a time basis per reg, and I think it's happening, it's happened in some cases, and it's a matter of us getting there as leaders in these organizations.
And I think it's a little bit like show me, right? To use that Alabama state expression, show me, right? And I think we have to show people how these things incrementally can make the solution better, actually. So I think that's very true.
Absolutely,
yeah.
Absolutely.
So we think about edge AI, it tries to operate in a very deterministic OT world, right? And today we have a lot of controls in place that are geared towards towards managing the systems and safety. How do you then introduce something like AI, which is more probabilistic in nature, on top of that? How do you make the two coexist so that you can, like, both they can work well together, they can complement each other, and how do you basically move from one to the other, allow one to take more decisions, more control?
Yeah, great question. To me, there is something sacred. We don't mess with safety, right? We are in a hazardous industry, we like it or not, we don't mess with it. So there are rules, regulations, controls, separate network, proper network segmentation, etc. I'm by no way means a network engineer, but there are separate networks which are meant to manage the safety system. So if you were to say that, look, I want to be able to see the value of these advanced technologies in operations, I think we need to think in two steps in my mind, right? One, you have this deterministic layer, which probably has another sub-layer for safety, which you don't touch, full stop. I mean, that is, if you have a high signal arrive because of a gas pressure, system should shut off, period, right? You also have the ability to bring in some advanced controls, process controls. I mean, the process control industry over the last several decades have improved, so we should be able to bring that, and we have brought that efficiencies in our operations. But then there is this, I call it the whisperer to the control system, right? How can I enable the control system to be a little bit more expansive in its nature? Right? How do I tell that, hey, look, you have these wells, or you have these compressor stations, or you have these pipelines, and if you make this micro adjustment, if you make this small adjustment, this is the benefit you can receive, whether it is increase in production or reduction in electricity consumption, or whatever that operational KPI is, right? So I think we have to think about this from a proper network segmentation, architectural standpoint upfront. Now, like it or not, we are going to live with a lot of brownfield engagements where systems are the way it is. So it behooves upon us to say, how do you make sure that you can properly bring these three things? Safety level, no touch. You bring your ability to control better, and then, of course, you bring the ability to add this whisperer to the control system.
Excellent. That makes a lot of sense. I think it's layers, right? It's layers. Just like we have in network security, all the other historically, it's all about the layers in the system. So another area that I feel is getting a lot of attention, and we talk to people in the oil and gas industry, people are trying to figure out what's next or how to go about accomplishing it, is around introducing virtual controllers. And we think about AI, and what AI is doing a fantastic job is it's ingesting data, and it's detecting maybe an anomaly, or it's detecting a change in some flow or measurement that needs to be adjusted. And obviously the way to do that is through PLCs today, but people are trying to figure out, how can I bring the same kind of innovation and flexibility I get with AI, and bring that to the whole virtual controller world? How do you see that happening, both in the brownfield situation and basically across the industry? How do the two go from just detecting to also now having action based on that at the edge?
Yeah, I think this whole rip and replace mindset doesn't work, right? We have to figure out how you bring technology to somewhat, let's say, wrap and extend or wrap and expand, right? So we have to figure out, how do you go from the existing controllers, the PLCs, the RTUs, they work, they do a great job, people are used to it, right? They're already trained on that, let's not make a change. But how do you bring this incremental, perhaps in some cases even monumental value to that, right? Now, so yes, I think virtualizing controllers and being able to bring some software layer to enact on your controls smarter and better is definitely happening, is needed, and will happen, I think, in accelerated fashion going forward. But I think one big elephant in the room at that point is cybersecurity, right? As soon as you start virtualizing these controllers, your CSOCs don't sleep in the night. So yes, that is a real problem. But again, that boils down to how do you architect your deployment properly and kind of deliver that value to the chap who's going to the field.
Yeah, for sure, absolutely. The key is, and the point is well taken, right? It's like there's existing processes in place, control systems, and you need to be able to evolve them with this new technology over time. You just cannot do rip and replace. You've got to basically wrap around it. I think this is the expression I've heard you use. So AI is great, and it always works very well in the lab, right? I think we all see that, hey, someone can demonstrate the ability of these models to detect unusual cases, report them when they're in the lab. But when it goes into the field, suddenly the conditions are different, the data is different, the frequency of data, the cleanliness of data is different. How do you deal with the fact that when you push it into the real world, the anomalies that look so accurate when we worked in the lab now look a little off, they're not as useful. After a while, they're creating so many errors or so many alerts that people start to discard them, the boy that cried wolf. How do you address that in the real world?
Yeah, I think this is probably the most important reason why AI projects die or fail, right? I think the speaker just before us, Padraig, if you recall, I think there was a good, positively negative message conveyed about how AI is or how AI is adopted. Very, very refreshing. We will succeed in labs. We know that, right? I mean, any data science university around the world you go, I can bet half my salary today that they have an ESP, electrical submersible pump, prognostic health management, failure prediction, whatever you want to call it, problem. It's there today, but it's not adopted at scale. And that's exactly comes to what you're highlighting, right? I think we throw a lot of these lab success. And again, don't get me wrong, data scientists are super smart.
Absolutely.
They develop these models. But then you operationalize that in a way which cannot be adopted at scale. And this is where I think, when you start thinking about, I have a model, I need to operationalize this, to me the phrase which comes to my mind is edge AI. I should be operationalizing this at the point where data is being generated.
Yep.
I should be operationalizing these models to consume that data, process the data, create those insights, and then take an action on that insight. Because many a times, the time from an insight generation till the time for that action to be taken in operations, right? I'm not talking about supply chain. I'm not talking about, like previously was spoken about contract management and things like that. I'm sure there's value. But in the operations where the so-called rubber meets the road or technology meets the desert sand or whatever you want to call it, I think that is the show thing, what you mentioned before, right? Show me that it adds value. Show me that it makes my life easier.
Yep.
I think we have to get to the point where we can have an architecture and infrastructure which can deploy solutions seamlessly and be able to manage those models as well, the vintage of those models, et cetera.
Absolutely, I think it's key. One last topic before we switch a little bit is securing the edge, right? One thing I've learned, every conversation I have with folks in the oil and gas industry and other industries as well, manufacturing, automotive, all the other verticals that we play in, the conversation always starts with security. If you cannot convince them from the get-go that the solution is secure, the conversation ends there. And I think it's doubly a challenge at the edge, right? I mean, we all know the challenges with securing stuff in the data center, and we lean heavily on hyperscalers to do a lot of that, and then we have to complement that ourselves. But when it comes to the edge, you're kind of on your own, right? So how do you ensure that when you're deploying apps and models at the edge, and particularly now as we talk about AI models, and AI models and the data they're running on is going to be the intellectual property and the value where a lot of companies harness the value and revenue going forward. How do you secure that at the edge? How do you make sure that no one can tamper with devices? How do you make sure no one can see what the model is doing? No one gets access to the data? Because these devices are literally out there in the wilderness with very little security around them. So there's both a digital and a physical security aspect.
Yeah, I think this is, I fully agree with you. I think this is probably one of the most important questions in operations. I think probably a conversation killer if it is not addressed properly up front, right? Yep. I was in a recent discussion with someone and they said, look, our systems are completely air-gapped. Nothing comes into out or out to in. And my argument was, fantastic. That means you're not even optimizing the system. You're just running it the way it is, right? So I think there is an engineered risk management which one will have to follow. In the industry which we are so actively part of and leaders of, management of change, the MOC process, yep, I think is made very well for hardware changes, which typically happens, years time frame, maybe a decade in some cases, right? In the software world, that's happening months and faster in some cases. So I think there has to be a proper MOC management of change protocol which needs to be adopted as well. So yes, I think I agree. Technologically, architecturally, things have to be aligned properly, but there is that element of how do I make sure I can adopt these technologies to derive that value.
Okay. Good. That makes a lot of sense. I think when we see security, and it's a constant, you've got to be constantly vigilant. So even though you might pass the CISO requirements the first day, every year we find we got to see audits, people are looking for audits, demonstrating that you're not just standing still, but that you're improving your security profile and adjusting it to the new threats that are being coming to life out there. So I think if we try and bring it all together, right, I think what you describe is that there's a bunch of challenges here that we face, right? So how do we take great concepts from a lab, from a design, and how do we actually roll those out at scale? Like, what are the characteristics, do you think, of systems that have to enable mass deployment in very harsh environments where you're operating in everything, oil and gas, for everything from freezing temperatures to 40 plus, 45 plus centigrade. How do you manage all that? How do you do that efficiently?
And I will take this opportunity to kind of re-ask you that question, Padraig, because I think there is a little product story here as well. But just from a process standpoint, I think it's important that the things which we just spoke about, architecture, MOC, making sure the value is demonstrated, etc. But I'm going to kind of spin that back to you, because I think it's important. I think you've started off the slide with ZEDEDA there. I think it's important if you could also help articulate the message around how does this tooling enable that deployment, that scalability, and the seamless interaction, with the edge.
Well, I think what the tooling does, there's a number of things that have to be accomplished, right? One is when you go to deploy at such a mass scale in such a diverse environment, be that somewhere in West Texas, somewhere up in Canada, somewhere in the Middle East, somewhere in Norway, right? They're all very different environments, and you have to have tooling that allows you to deploy successfully in those deployments. I think given the nature of the location, you also need to be able to do a zero-touch deployment. I think going forward, we've got to figure out how to eliminate the need for truck rolls. We've got to figure out how to eliminate the need to send very skilled people when you're deploying in new locations. And I think there are tools that allow us to do that now. Basically, you should be able to take your device, load your software, ship it to the location, plug it in, and it should be able to basically come online with the apps and start operating. And I think that zero touch is very important to be able to do this type of work at scale. I think zero trust, back to the topic of security. I think the challenge with when you're operating in the wild is that you've got to ensure that there is no ability for people to interfere or monitor or access the data that you're collecting or whatever controls that you're operating there. They've got to be secure. And I think it's key that the devices out there are functional, but locked down in a way that actually no one can actually interfere with them, put malware on them, or get access to the IP models that you're running, AI models that you're running going forward. And then I think the other thing is you need to be able to update these devices on a regular basis. You need the ability through a click of a button to either an air-gap solution, or if you're running on hyperscalers, you need to be able to update the software without having to have someone go out and do it. And I think these are the things that we've seen are required in order to be able to operate truly at scale and be able to manage your systems in a more efficient way. Because technology is only good if you can answer questions like, how do you bring value? I think as a previous speaker said, right? How do you reduce the number of truck rolls? How do you update your software to make your wells run more efficiently on a daily basis as opposed to once every 3 months when someone could roll around? How do you address CVEs from a central location, do that automatically, autonomously, as opposed to having to do it manually? And it's that kind of efficiencies that's going to justify this type of technology going forward. So with that, I think we have 2 minutes left. Any questions from folks?
Oh, this is for us.
Yeah, okay, yeah.
I could see some resemblance here. But
All
I don't know
right.
if
So
it's
the
for us.
first question, can you talk about where human judgment still sits in the architecture and how you decide which actions should remain human in the loop versus fully automated? Garud?
Let me take a stab at this, and I think you should probably add some as well, right?
Yeah.
So we spoke about trust, and I think trust, it's difficult for human beings to let go. We like it or not. There is, I want to take all the decisions which concern my immediate environment, right? That's typically what we end up doing. So there are some cases in our operations where that piece is super critical still, right? Sometime in the future, maybe with all the advancements, we could argue that we can reduce the dependency there. But when you start talking about safety, when you start talking about operations which, I'm not talking about our personal data being leaked out, but I'm talking about a tank exploding, serious stuff which could harm us. I think we still need to have a proper risk assessment in place with the right human in the loop. We can go through this in detail, but I think there is still a reason why a human in the loop in operations must be there. We are not fully mature yet. We are still on that maturity curve, as we've discussed before.
There's a lot of industry knowledge that's been built up over hundreds of years that has not been codified, and it's not sitting in ChatGPT or Claude yet. No doubt about it. Another question, someone asked a question about what's the real value of putting AI in the field directly compared to how we use it today? So I think today people are still running some AI models in the cloud. I think the value of running it at the edge, particularly for oil and gas, there's a number of reasons. One is a number of the conditions that you want to operate and control, maybe through virtual controllers, adjustment of conditions in a well. Some of those require milliseconds of round-trip time. So having the ability to do the AI at the edge and actually communicate with your virtual controller, with your hardware controller to make those changes, I think allows you, if you're running at the edge, to do that. If you're in the cloud, it's problematic. I think the other thing too...
If I just to add to that, Padraig,
Yeah.
millisecond is fantastic,
Yeah.
but let's be honest with ourselves. In some cases, it is days, weeks,
Yes.
even before an insight which has been generated in this fancy office gets implemented.
Yeah.
Right? So I think there is a value in reducing that latency. We get hung up on this real-time, oh, we don't need real-time, latency is okay. But I think there is still value in being able to act on that insight which you have spent so much money to generate. Right?
I think the other condition too is we're operating in very remote places where connectivity is spotty, right? And if you're relying on your AI running in the cloud, I think there are going to be quite a number of occasions where it's not going to be available. So having it at the edge guarantees you that operation.
Absolutely. Yeah. I just picked one more question from there, which I thought was very interesting.
Just really quickly, we're really over on time.
Absolutely. Yeah. Data integrity. Yeah. This is a topic which keeps coming up over and over again. We bring data to cloud. The supply, you have already paid for the supply chain of the data. The data shows up in the cloud, and then we run data gaps. We try to understand, is the data good enough for whatever I want to use it with? Just imagine if we move that function to where the data is being generated, and perhaps physics inform it even, if required. Yeah. This is the ability which I think Edge AI can bring to the table to scale.
And those physics models, I think, is the special sauce. Yes. Thank you.
All right. Thank you.